Write in the missing numbers. First, we have something plus 85 equals 200. So if we have a missing number addition problem, we can subtract to find the missing number. So work out 200 minus 85. We might be able to do that mentally, but if we use column subtraction, we can't do 0 minus 5. We go to the left, but we still have a 0, so we go to the left again. 1 less, 1 in front, and now 1 less than 10 is 9, 1 in front. So 10 minus 5 is 5, 9 minus 8 is 1, and 1 minus nothing is 1. So we get 115. Now 4 times something equals 120. So this time we have a missing number multiplication, and we can always find the missing number in a multiplication problem by dividing. So we can work out 120 divided by 4. We could use short division, or we could get our answer mentally. So 12 divided by 4 is 3, and if we have one end zero in the dividend, we need an end zero in our answer. So 4 times 30 is 120, because 120 divided by 4 is 30. And finally, we have 120 minus 51. Using column subtraction, we can't do 0 minus 1, so go to the left, 1 less, 1 in front. 10 minus 1 is 9. We can't do 1 minus 5, but 11 minus 5 is 6. So our answer is 69. Here is a square. What fraction of the square is shaded? Well, remember, when we're finding fractions, the numerator, or the top part, tells us how many parts we have, and the denominator tells us how many parts there are altogether. So how many parts do we have? We have 2 parts that are shaded, or 2 pieces shaded, and we have 1, 2, 3, 4, 5, 6, 7, 8 pieces altogether. So the numerator is 2 and the denominator is 8. So 2/8 of the square is shaded. Now we could simplify that to 1/4, or we could just leave our answer as 2/8. These are the prices of sandwiches, drinks and fruit. Shireen buys a tuna sandwich, milk and a pear. How much does she pay? So we need to find the total of these 3 items. First, if we add the cost of a tuna sandwich, so £1.70, and the cost of milk, so 55 pence, we can then add the cost of a pear to that total. Now 55 pence can be written as £0.55, and if we add that to £1.70, we get £2.25. So that's the total cost of a tuna sandwich and milk. So if we add 20 pence for the cost of a pear, and remember 20 pence is the same as £0.20, that gives us the total cost of £2.45. These are the prices of sandwiches, drinks and fruit. Mike has 80 pence to spend on a fruit and a drink. What 2 things can he buy for exactly 80 pence? So he's going to buy a fruit and a drink and needs to spend exactly 80 pence. If he buys milk for 55 pence, he can then buy a melon for 25 pence, because 55 and 25 make a total of 80. So he could buy milk for his drink and melon for his fruit. And we can check 55 plus 25 gives us a total of 80. Measure accurately the length of the diagonal of this square. Give your answer in centimetres. So a diagonal is a line that joins opposite corners. So the diagonal is this line here. To measure it, we can take our ruler and make sure that 0 on the ruler is lined up with one end of the line, and if we look to the other end, we can see that it's gone past 8 centimetres, and then we have 5 of these little lines. so we can write our answer as 8.5 centimetres, because that's the same as 8 centimetres and 5 millimetres. Use each number card once to make the answer to each calculation an even number. So we have 3, 4 and 5, and we need to remember that an even number is a number that ends in 0, 2, 4, 6 or 8. So that's a number in the 2 times table. So we have 5 times something, and our answer needs to be an even number. Now 5 times 3 is 15, but that ends in a 5, so that's odd. 5 times 4 is 20, and that's an even number because 20 ends in a 0. 5 times 5 would be 25, but that would be an odd number because it ends in a 5. So the card we need to use here is the 4. Now we have 12 divided by something. If we divide 12 by 3, that gives us 4, because 4 times 3 is 12. And 4 is an even number, so we can use 3 as this card here. And if we have 9 plus 5, that gives us 14, which ends in a 4, so that's an even number. Now notice, if you multiply an odd number, so 5, by an even number, your answer will be an even number. If you divide an even number by an odd number, your answer will be an even number. And if you add 2 odd numbers, your answer will always be even. Alan has 45 beans. He plants 3 beans in each of his pots. How many pots does he need? So here we need to divide 45 by 3. And the reason why we use division is because we know the total, we know how many there are in each thing, and we need to find the number of things. So here the number of pots. So 4 divided by 3 is 1 remainder 1, and 15 divided by 3 is 5. So that means he needs 15 pots. He's planting 3 of his beans in each plot, so if we have that 15 times, that gives us 45 beans altogether. Now Layla puts 4 seeds in each of her pots. She uses 6 pots and has 1 seed left over. How many seeds did she start with? So she's used 6 pots, and there are 4 seeds in each of those, so that's 24 seeds altogether in the pots. But she also has 1 seed left over. So if 24 seeds are in her 6 pots, with 4 seeds in each, and she has 1 left over, that's 25 seeds altogether. So we have 4 seeds in each pot, and we have 6 pots, but then there's 1 seed left over, so that's 25 seeds altogether. Here are 5 shapes on a square grid. Write the letters of the 2 shapes which have a line of symmetry. So a line of symmetry is a line down the middle of a shape where we have the same reflected on both sides. So with shape A, we have a line of symmetry here. We have the same reflected on both sides because we could fold one side over so that it completely covered the other side with nothing overlapping. But shapes B, C and D do not have a line of symmetry. Now we could draw a line to split shape D in half, but it wouldn't be a line of symmetry because we wouldn't be able to fold one side over so that it completely covered the other side. But shape E does have a line of symmetry here. So our 2 shapes are shape A and shape E. Calculate 13.6 minus 2.8. So we can set this out as a column subtraction, making sure that we have our decimal points lined up. We copy the decimal point into our answer, and then we can't do 6 minus 8, so go to the left, 1 less, 1 in front. 16 minus 8 is 8, 2 minus 2 is 0, and 1 minus nothing is 1. So our answer is 10.8. Abby takes the temperature outside at midday on the first day of each month. The graph shows her results from January to December. How many months on the graph show a temperature between 10 degrees and 20 degrees? So we have the temperature labelled on the side, so we can draw a line across 10 degrees and a line across from 20 degrees. And we want the months that are between these temperatures, and we can see that we have 1, 2, 3, 4, 5 crosses between our lines, so that's 5 months. Now find the difference in temperature shown on the graph between July and August. So if we find our temperature for July, we can go up and then across, and we can see that that's between 15 and 20, but it's slightly closer to 20. So I would estimate the temperature in July was 18 degrees. Now, if we find the temperature for August, we can go up from August, draw a line across, and we can see that that's 25. Now we need to find the difference, so we need to subtract. 25 minus 18 is 7, so the difference in temperature is 7 degrees. A shop sells 3 types of sunglasses. What is the difference in price between the most expensive and the least expensive sunglasses? So the most expensive sunglasses we can see cost £5.85, and the least expensive are £2.99. Now we need to find the difference, and to find the difference we always subtract. So if we use column subtraction, we can copy down the decimal point and then subtract as normal to get a difference of £2.86. We could also subtract £2.99 by first subtracting £3 and then adjusting by adding 1 pence. So £5.85 minus £3 is £2.85, but that's subtracting £3, and we only needed to subtract £2.99, so we've subtracted 1 pence too much. So if we adjust by adding 1 pence, that gives us the same answer, a difference of £2.86. Now the shop also sells sun hats. Ryan buys the £4.69 sunglasses and a sun hat. How much change does he get from £10? So he spends £4.69 on sunglasses and also buys a sun hat for £3.29. If we add those together, we can see that he needs to spend £7.98. Now if £7.98 is what he spends and he pays with £10, we can calculate the amount of change by finding the difference. So work out £10 minus £7.98. Remember, £10 can be written as 10.00, and then we can copy down our decimal point. But here we need to do a lot of exchanging. We can't do 0 minus 8. If we look to the left, we have a 0, then another 0, so we need to go all the way over to this 1 less, 1 in front, 1 less than 10 is 9, 1 in front, 1 less than 10 is 9, 1 in front. And now we can subtract to get an answer of £2 and 2 pence. We could also solve this in a different way. So once we've worked out that he spends £7.98, we can find the difference between that and £10 first by adding £2 to get £9.98 and then adding another 2 pence to get £10. So we found the difference because we've counted on from £7.98 to £10, and to do that we had £2 and then 2 pence added. So that's the amount of change that he gets. A film starts at 6:45 p.m. It lasts 2 hours and 35 minutes. What time will the film finish? So we need to add 2 hours and 35 minutes to 6:45. But remember, when adding time, we can't use column addition. We need to draw a timeline. So the film starts at 6:45. If we first add 2 hours, that will take us to 8:45. But now we need to add 35 minutes. 45 plus 35 is 80, but there are only 60 minutes in an hour. So first, let's add to take us to the next hour, so take us to 9 o'clock. If we add 15 minutes, that will take us to 9 o'clock, because there are 60 minutes in an hour, and 45 plus 15 is 60. But that's adding 15 minutes, and we need to add 35 minutes. So we can add another 20 minutes, because 15 and 20 make 35 together. So 20 minutes after 9 o'clock is 9:20, so that's the time that the film will finish. Here is a sorting diagram for numbers. Write a number less than 100 in each space. So on this side, we have a square number and not a square number. So we need to remember that a square number is what we get when we multiply a number by itself. And then at the top, we have even and not even. So an even number ends in 0, 2, 4, 6 or 8, because an even number is a multiple of 2, or a number in the 2 times table. So for this box here, we need a square number that is also even. So we could have 4 here, because 2 times 2 is 4, so it's a square number, and it's an even number. But there are lots of other possibilities as well, as there are for all of our boxes. Now here, we need a square number that is not even. So we could write 9 here, because 3 times 3 is 9, so it's a square number, but it's not an even number. Here, we want a number that is not a square number, but is even. So we could have 6 here, because you can't multiply a number by itself to get 6, but it is an even number. And now we want a number that is not a square number and not even. So we could have 7 here. It's not a square number because you can't multiply a number by itself to get 7. And it's not even because even numbers always end in 0, 2, 4, 6 or 8. This is a drawing of a pentagonal prism. Tick the one shape that is a net for the pentagonal prism. So a prism is a 2D shape that's been stretched out. So with a pentagonal prism, we'll have a pentagon on this end, a pentagon at the other end, and then we'll have rectangular faces connecting them. And we'll have 5 rectangular faces because there are 5 sides in a pentagon. So the problem with this diagram here is that it's only got 4 rectangular faces, so there's a missing rectangle. The problem with this diagram is that these pentagons are on the same side, so they will overlap. This net does work because we can have one pentagon here. We can fold up each of these rectangular faces, and then this other pentagon will be able to fold over the top, so make a pentagonal prism. The problem with this net is that these 2 rectangles will overlap, and then this edge here won't have a rectangle covering it. And the problem with this diagram is that there's only one pentagon, and with a prism we have the same 2D shape on both ends. Write in the missing numbers in this multiplication grid. So we can see how multiplication grids work, because we have the number 20, and to the left we have 4, and above we have 5, and 4 times 5 is 20. So if we want to find this box here, we have 36 below it. So 4 times whatever this number is equals 36. So really, we have a missing number multiplication. 4 times what is 36? Well, 36 divided by 4 is 9, so our missing number is 9. And here we have 32, so 4 times something is 32. Well, 32 divided by 4 is 8, and that means that 4 times 8 is 32. Now, let's find this box here. We have something times 5 is 35. 35 divided by 5 is 7, so that's our missing number. And here, something times 5 is 30. Well, 30 divided by 5 is 6, so 6 times 5 is 30. And what we should do when we filled out the multiplication grid is check that it works with other values. So let's look at 63. We have 7 to the left and 9 above, and that makes sense because we know that 7 times 9 is 63. Or if we take this number here, we have 48, and to the left we have 6, above we have 8, and that makes sense because 6 times 8 is 48. Millie has some star-shaped tiles. Each edge of a tile is 5 centimetres long. She puts 2 tiles together to make this shape. Work out the perimeter of Millie's shape. So remember, the perimeter of a shape is the distance around the outside of the shape. We know that each side is 5 centimetres, so what we need to do is to count or work out how many sides we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 sides around the outside of our shape. Now if each of these sides is 5 centimetres, we can find our perimeter by working out 18 times 5, and that gives us 90, so the perimeter is 90 centimetres. Notice, to find our perimeter, we don't count these sides here that are on the inside of the shape. And that's because, to find perimeter, we only count edges on the outside of the shape, so we don't need to count these edges here when we're finding our perimeter. Mr. Khan makes blackcurrant drink for a party. He pours blackcurrant squash into a jug. How much water must he add to make 500 millilitres of drink? So first, we need to work out how much blackcurrant squash he's poured in, and then we need to find the difference between the amount that he has and 500, because the question asks how much more, so we're finding the difference. To find how much he has, we need to work out what these little lines on our scale represent. So to get from 100 to 200, we have 1, 2, 3, 4, 5 lines. Now the difference between 100 and 200 is 100, so if we divide that by the number of jumps, we get the value of each line, and 100 divided by 5 is 20. So with each of these little lines, we have an increase of 20. So we have 100, 120, and then 140. To check that we've got this right, we could keep going. So we have 160 here, 180, and then another 20 takes us to 200. So we know that he has 140 millilitres and needs to make 500. So we need to find the difference and subtract 140 from 500. Using column subtraction, that gives us 360. So our answer is 360 millilitres. He has 140 millilitres of squash, so if he adds 360 millilitres of water, that will give him 500 millilitres altogether. Calculate 31.6 times 7. So we can set this out as a short multiplication, And because we have a decimal point in the question, we need to remember to copy the decimal point into our answer. Now, 6 times 7 is 42, so 42. 1 times 7 is 7, plus 4 is 11, so 1, 1. And 3 times 7 is 21, plus 1 is 22. So our answer is 221.2. Marie is the presenter of a weekly radio show. She always plays 5 new songs for every 2 old songs. Last week, she played 15 new songs. How many songs did she play altogether? So we know that the ratio of new songs to old songs is 5 to 2. And we know that she played 15 new songs last week. Now 5 times 3 is 15, and 2 times 3 is 6. So she played 15 new songs and 6 old songs, which means that she played 21 songs altogether. Julie says I added 3 odd numbers and my answer was 50. Explain why Julie cannot be correct. So remember, an odd number ends in 1, 3, 5, 7 or 9. Now 50 is an even number because it ends in a 0. And if we add 3 odd numbers, our answer will always be odd. If we add 2 odd numbers, our answer will be even, but adding another odd number means that our total will also be an odd number. So 3 odd numbers can't add up to an even number. Here is a kite. Write the coordinates of point D. So we need to write the coordinates of this point here. And remember, the first coordinate we write is our x coordinate. So D is in line with B, which has an x coordinate of 5. So the x coordinate of D will be 5 as well, because we can see that this is in line. But now we need to find the y coordinate. The y coordinate of C is 4 and of A is 4, so this is a straight line. So we can write 4 on our graph here. And we also know that the y coordinate of B is 6, so we can plot 6 as well. Now the difference between 4 and 6 is 2. But we know that with a kite, we have a line of symmetry because this length is the same as this length and this length here is the same as this length. So if point B is 2 more than 4, then point D will be 2 less than 4. So the y coordinate for point D will be 2. So D has the coordinates 5, 2. Calculate 900 divided by 45 times 4. Now because 45 times 4 is in brackets, we need to do that first. So if we use short multiplication, that gives us 180. So now we need to work out 900 divided by 180. One way to divide is to count up in steps of the divisor until we get to the dividend. So count up in steps of 180 until we reach 900. So 180 is of course 1 times 180, but if we add another 180, that gives us 360 for 2 times. We can keep going. We get 540 for 3 times, 720 for 4 times, and then we can work out that 5 times 180 is 900, and that means 900 divided by 180 is 5, so that's our answer. Liam thinks of a number. He multiplies the number by 5 and then subtracts 60 from the result. His answer equals the number he started with. What was the number Liam started with? So there are 2 ways to solve this question. One is to represent what happens with a bar model, and the other is to use trial and error. If we're using a bar model, we can show a bar to show the number that Liam thinks of or starts with. We know that he multiplies the number by 5, so we can show 5 bars to show that he's multiplied what he started with by 5, and then when he subtracts 60 from the result, his answer equals the number he started with. So if we subtract 60, then we get the same as what he started with. So we can see that these 4 bars are the same as 60. So if we divide 60 by 4, we know that each bar must be 15. So Liam started with the number 15. And we can check that it works because we can multiply 15 by 5. That gives us 75. And then when we subtract 60 from 75, we get back to 15, so back to the number that we start with. We could also use trial and improvement. So we can pick a number almost at random. So if we start with 20, we can multiply that by 5 to give us 100, and then subtract 60, so that would give us 40. But 40 isn't the same as 20, and his answer equals the number he started with. So we need to try something else. If we use 12, 12 times 5 is 60, but then his answer, so 60 minus 60, would be 0, and 0 is not the same as 12. So when we tried 20, what we got was too many, and when we tried 12, what we got was too few. So we know that we need to find or try a number between 12 and 20. So then if we tried 15, we'd find that it would work because we get 15, and that's the number we start with. Here is part of a train timetable. How long does the first train from Edinburgh take to travel to Inverness? So with timetables, we need to remember that each column will be a different train. So we need to find the first train from Edinburgh. This train here doesn't stop at Edinburgh, but the first train leaves Edinburgh at 9:35. We want to know how long it takes to travel to Inverness, and this train gets to Inverness at 13:10, or 10 past 1 in the afternoon. So we need to find the difference between these times. On a timeline, if we start at 9:35, so when the train leaves Edinburgh, we can add an hour to get to 10:35, then another hour takes us to 11:35, and another hour takes us to 12:35. Now, one more hour would take us to 13:35, but we only need to get to 13:10. So instead, let's think how many more minutes to get to the next hour. Well, if we count on 25 minutes, that takes us to 1 o'clock in the afternoon, because there are 60 minutes in an hour, and 35 plus 25 is 60. And then to get to 10 past 1 or 13:10, we just need another 10 minutes. So altogether, that's 3 hours, and then 25 plus 10 is 35 minutes. So the first train takes 3 hours, 35 minutes. Now Ellen is at Glasgow station at 1:30 p.m. She wants to travel to Perth. She catches the next train. At what time will she arrive in Perth? So in this timetable, we have 24-hour clock times, but here we have PM. So to change PM to 24-hour times, we can add 12. So she gets to Glasgow station at 13:30. So this train here, which leaves at 13:15, will be too early. She'll need to get the next train after 13:30, so that's the one that leaves at 13:45. At what time will she arrive in Perth? Well, we can go across from Perth, and we can see that this train gets to Perth at 15:15, or at 3:15 p.m. Calculate 5% of £3,600. So remember, a percentage is a fraction with a denominator of 100, so 5% is the same as 5/100ths. And to find a fraction of a number, we can first divide by the denominator and then multiply by the numerator. So we can work out 3,600 divided by 100 and then multiply that answer by 5. Now, because we have end zeros in our division question, we can cancel them, and then 36 divided by 1 is of course 36. Then we can take that answer and multiply by the numerator, so work out 36 times 5. That gives us 180, so our answer is £180. Here is an equilateral triangle inside a square. The perimeter of the triangle is 48 centimeters. Calculate the perimeter of the square. So the perimeter is the distance around the outside. So the perimeter of the triangle is 48, and we're told that it's an equilateral triangle. And that's important because in equilateral triangles, all sides are the same length. So these three sides add up to 48. So to find one side, to find this side here, we can divide 48 by 3, and that gives us 16. So we know that the sides of the triangle are all 16 centimeters. They're all the same because it's an equilateral triangle, and that gives a perimeter of 48 centimeters because 16 plus 16 plus 16, or 16 times 3, is 48. Now we want to find the perimeter of the square, and with a square, all of the sides are the same length. So if this side here has a length of 16, then all of our other sides have a length of 16 as well, because in squares, all sides are the same length. So to find the perimeter, we need to work out 16 plus 16 plus 16 plus 16, or 16 times 4, and that gives us 64 centimeters as the perimeter of the square.